What is up, multivariate gang? Today we are going to be continuing our discussion of vectors and talking about vector addition. Alright, so what is vector addition? Well, just in the same way that you can add scalars together, 2 plus 2 equals 4 and all that, you can add vectors together. And of course, as we know, vectors have a direction, and that makes the addition of them not too complicated, but a little more complicated. So let's get right into it. All right. So when we are adding vectors, we are doing two things. We are doing something geometrically and numerically. So first, geometrically. I've got this vector. This vector A. This vector A is 1, 2, 3, 4, 5, 6 units long in the x direction. And 1, 2, 3, 4 units long in the y direction. All right. Got this other vector B. It is -1, -2 units into the x direction, and 1, 2, 3 units in the y direction. All right. Now I want to add. Here, do a different color. Vector A, vector B together. Oops, I spoiled it. Let's say that they're just somewhere. These two vectors are just somewhere in two-dimensional space. No specific location whatsoever. So the way I add these vectors is I put the tail of the second one onto the head of the first one. That's what I'm doing geometrically. And I am drawing a new vector from the tail of the first one to the head of the second one. This pink vector is vector A plus B. Geometrically, when you add two vectors, that is what you are doing. All right. Now, numerically, what are you doing? How can you actually find the xy components of these vectors? Well, we know that in the x direction, we would go 1, 2, 3, 4, 5, 6 over for vector A, and it looks like we go 1, 2 back for B for 1, 2, 3, 4 for A plus B. And so that, and let's go back to pink, is just 6 minus 2. Or 6 plus -2. And in the y direction, we go up 4 for vector A, then we go up 3 more for vector B. 4 plus 3. That gives us 4 and 7 for A plus B. So generally, when we add vector A and vector B, all that is we're adding the x components together, and we are adding the y components together. Exact same thing in 3 space. If we have vector A, some three-dimensional vector, x component ax, y component ay, z component az, got some vector B, x component bx, y component by, z component bz, their sum or their resultant vector, resultant is another word for that, is ax plus bx, ay plus by, and az plus bz. Easy peasy. That's simple. Okay, let's do an example problem. Find vector v plus vector w if vector v equals 1, 4, 7, and vector w equals 3, negative 2, 3. Well, we know that v plus w is just vx plus wx, vy plus wy, vz plus wz. So that's 1 plus 3, 4 plus negative 2, which is minus 2, 7 plus 3, which is 4, 2, and 10. Easy peasy. We'll pick it up again when we talk about vector subtraction in the next video.